So for the 3 month moving average, to find the forecast values, I calculated the average of the first three sales value, which goes from B3 to B5 in cell C6. Then I dragged the formula down to cell C14. To find the absolute deviation, I calculated the absolute value of the difference between sales and forecast value in cell D6. Absolute percentage error is calculated by the formula as absolute deviation divided by actual values times sales times 100. In cell E6, they take cell D6 divided by cell B6 times 100 and then drag the formula down to E14. Finally, I get the mean absolute deviation by finding the average of absolute deviation values. In cell D15, I use the formula average D6 to D14, and then to find the mean percentage error, I find the average of the absolute percentage error values. In cell E15, I use the formula average by E6 to E14. So now for the linear trend forecast. For the linear trend forecast, I applied a regression-based approach to estimate future sales based on time. The forecast values were calculated using the formula forecast is the same as intercept plus slope times month. Based on the regression output, the intercept was 211.5909, and the slope was 16.1014. Using these values, I entered the formula 211.5909 plus 16.1014 times A3 in cell F3, which uses the month number in column A to compute the forecasted cell. So this formula was then dragged down to cell F14 to generate forecast for all months in the dataset. So after that, to assess the accuracy of the forecast, I calculated the absolute deviation in cell G3 using the formula AVS by B3 minus G3, which gives the absolute difference between the actual cells and the forecasted values. In cell H3, I calculated the absolute percentage error using the formula H3 divided by B3 times 100, which expresses the forecast errors as a percentage of actual sales. Both formulas were dragged down to raw 14 to apply the calculations across all the forecasted months. And then to summarize the forecast performance, I calculated the mean absolute deviation, which is the MAD, by using the formula average by G3 to G14 in this case. And then in cell G15, and the mean absolute percentage error, which is the MAPE, by using average H6 to H14 in cell H15. These two metrics provide a clear measure of the overall accuracy of the linear trend model. And the linear trend forecast is the better forecasting method here, which higher accuracy and lower MAPE. So now, on the spreadsheet model, on reference to the cell F11 to cell 16, I created a column of values from 20 to 50 with an increment of 5 in cell B17 to B23. I then select the cell range B16 to C23 and go to the data table and select column value D17. The one-way data table shows how food cost per person affects the total cost. So when food is $50 per guest, the total cost is $36,000. This helps evaluate how changing one input impacts the overall budget. Okay, then on reference cell F11 to cell B28, I create a column of values from 20 to 50 with an increment of 5 in cell B29 to B35, and a row of values from 5 to 30 with an increment of 5. I then select the cell range B25 to H35 and go to the data table and select column value D7 and row value D8. The two-way data table analyzes both food and drink. This is cost per person. At $35 for food and 15 for drinks, the total cost is 31,000. So this reveals optimal combinations to manage expense effectively. Uh, Finally, to select a goal seek and set cell F50 to the value of 20,000 by changing cell D46. Uh, so the goal seek determines the food cost needed to keep total cost under 20,000. By setting total cost to 20,000 and adjusting food cost, it finds 18 per guest meets the budget goal. So that's basically it.